You're welcome. Here we want to uh, solve this question. Is differential calculus, that is the concept of minimum and maximum, where you have to find the maximum and the minimum points of the curve defined by this and sketch the curve. Now, you can come across this one also in polynomial, asking you to sketch the curve like this. So here you can make use of the root of the equation to do that. Or here, make use of the minimum and the maximum point to do that. So here is uh, y equal to this. So the concept of minimum and maximum. So what's the principle? Here you have what we call necessary condition. For necessary conditions, you have uh, necessary condition. You have the y, the s equal to 0. So that is, if you have a curve like this. So what you mean by stationary point is the turning point. The point where this line turn to other direction, maybe from here up, and this point also. So this is minimum and this is maximum. So here you have the stationary point. As stationary point, the rate of change of y with respect to s is 0. So that is what we mean by what? The one that's first. Then the second is we call it sufficient condition. Is the one that states that the y, the x, that is the second derivative of this is less than or greater than 0. So this is what we call it sufficient condition. What does it mean? It will be at maximum when the second derivative is what? Less than 0. And it will be at maximum. It will be at maximum when this one is less than 0, and minimum when the second derivative is what? Greater than 0. So that is it. So you can now carry it out. That is, when this point is falling, that's what they mean by when this one is less. When this one is what? Here, when the second derivative here is what? Less. So you have the maximum. So at this particular point, and why this one is what? Rising. So look at it. From the first one, you have the y dx. So the y dx is what? 3x squared minus 12x plus 9. So you see that this one equal to 0. So that's it. So you can divide through by 3. Divide through by 3, you will have x squared minus 4x plus 3 equal to 0. Then you factorize this. You know how to factorize two numbers. What are the factors of 3? The factor of 3 are 1 and 3. So you need two numbers. That if you add them together, you get minus 4, which is minus 1 and minus 3. If you multiply them together, you will get 3. Minus 1 times minus 3 will give you plus 3. So here you will have x squared minus x minus 3x plus 3 equal to 0. So here you will have x squared. So x squared minus x into brackets minus 3x. Now minus times what? Plus will give you minus 3 equal to 0. So what will be the value? You factor out x, it will remain this. You factor out 3, it will remain this equal to 0. So you will have x minus 1, x minus 3 equal to 0. So, so that's what we have. Then from there, you can have x minus 1 equal to 0 or x minus 3 equal to 0. So that's what we have. Then x equal to 1 or x equal to 3. So at stationary points, so at the turning point, the value of x is this, and the value of y, the value of first x is this, second x is this. Because here is polynomial, so it's going to be like a sine wave or or trigonometric, what do you call it? So you have it like this. So at stationary point, s equal to 1 or 3. So let's have it there. Then the equation you get is what? 3s squared. Well, just leave it like that. So now the second condition, which is sufficient condition, is this taking second derivative of this. So you will have the y d squared the x squared equal to, so second derivative of this 2 times 3 is 6x minus 12. So at this second derivative, your answer, this is what you have. Then you are going to test at what point is is this curve minimum or maximum. So you get to know by this. Then what do you get as stationary point? Here is 1 and 3. Then when x is 1, what will be the value of this? So the y squared the x squared equal to 6 times 1 minus 12, which is equal to 6 minus 12. So you will have minus 6. So this one definitely is what? Is less than 0. So that you know that at point 1, the curve will be at maximum. So that's it. Again, the the square y the x square equal to 6 times, when s is here is when s is 3. So 6 multiplied by 3 minus what? 12. So you will have 18 minus 12, which is 6. So here you have 6. Now, definitely you know that 6 is greater than 0. So at point, at what? Point at s equal to 3, the curve will be at what? Minimum. So that's it. So you have determined the minimum and the maximum. Then the next thing you are going to do, the next thing you are going to do here at this particular place, you will have it as what? Maximum. And at this point, you will have it as what? Minimum. So that's what you need to know. Again, you want to find the value at what value of y and at what value of y. So for both. So when x equal to 1, what will be the value of y? Y equal to what? 1 cube minus 6 times 1 square plus 9 times 1 minus 4. So what you have here is 6 plus 9 minus 4. So definitely y equal to 0. So at this particular point, y is 0. So this minus this will give you minus 5 plus this 4. 4 minus 4 is 0. Again, when s is 3, we have 3 raised to power 3 minus 6 times 3 squared plus 9 times 3 minus 4. So what you have here is 27 minus 6 times 9 plus 27 minus 4. So this one is 27 minus 54 plus 27 minus 4. So 27 uh, so 27 plus 27 is what? 52. So 54. So 54 minus 54 is what? 0. So y will equal to what? Minus 4. So that will be the value of y when it's at what? Minimum. Then here you will have y equal to 0 or y equal to minus 4. So you can now sketch the curve Now look. So this is what you have. Here you have y-axis and x-axis. So look here. Now, what are the values you have here? So you can simply have 1, 2, 3, 4. 1, 2, 3. 1, 2. I have it like that. 1, 2. So here you will have 2 and 4. Minus 2 and minus 4. Here you have minus 1, minus 2, minus 3. 1, 2, 3, 4. So that's it. Then you want to draw it now at when this one is what? Here. Y will be 0. This is 0.0 here at this particular point. So, and then second one is 3 at this particular point. Then y will be what? Here. Here. So here is that's at minimum. So how is the curve going? So the curve can be like this. So that's it. So at this particular point, so the curve could be like this. If you want to do it perfectly, you can find the root of the equation for this. So you find the value for x. So it is then you will know how this one cut, where it cuts here and where it cuts here. Then what you have here now is at maximum. So x equal to 1 when this one is equal to 0. When it's at maximum. So the curve is at maximum point here, wherein this what minimum point. So that's it. If you have any question to ask, you are free to ask. Thank you for watching.